A changing magnetic field will produce an EMF, which will produce a magnetic field, both obeying Faraday's law of induction and Lenz's law. This means that when a solenoid, a coil of wire with end loops, has a current flowing through, the induced magnetic field will oppose the change. In effect, this slows down the current passing through the solenoid. This can be seen on our diagram to the right. Over here is a battery. As the current flows up and through our coil, there is a magnetic field being produced, which obeys the right-hand rule. As we input more and more current through our solenoid, our magnetic field would become stronger and stronger and stronger. However, due to Lenz's law, this producing magnetic field is going to start off at 0 and slowly increase, thus taking some time before the full magnetic field is achieved. The same is true for discharging. When the current is dropped or the flow changes, the induced magnetic field resists the change and will try and maintain a constant flow. This image over here is an inductor. As you can see, it's got lots and lots of coils all around a single donut. The donut will most likely have a ferromagnetic core, and its job is to produce as strong as magnetic field inside as possible and maintain that so that it's resisting the change of the current. So what is the EMF produced by an inductor? Well, the EMF of an inductor is equal to minus the inductance times by the change in current over a change in time. So how did we get that our EMF is proportional to our change in current over a change in time? Well, we know that EMF is proportional to the rate of change of our magnetic flux over a change in time. However, as the geometry is fixed for the coil, that is to say our A is constant, our magnetic flux is going to be the same as our changing magnetic field. Our change in magnetic field is going to be the same as our change in current. This gives us that our EMF is proportional to the change in current over a change in time. Inductance is a constant. It is dependent on the properties of the coil, just like capacitance. Inductance is measured in Henry. Henrys are volt seconds per amp, or ohm seconds. An inductor in a circuit will have a symbol like this. All circuits will have some inductance, however, without a coil, a solenoid, the inductance is negligible.